Hello, we are the Lizard Wizards, a team of students from WPI. Our project is the Terraduino, a reptile habitat regulation system. This project enables people to take care of their pets when they aren't physically present.
The Terraduino addresses 5 key habitat features for reptiles: humidity, temperature, soil moisture, lighting, and feeding. The system can either report to the user and self-regulate, or allow the user to manually make feature changes.
Major project goals include ease of install and use, modularity, non-obtrusive design, and Wi-Fi communication. We started by identifying and purchasing the materials to make the Terraduino work. The Arduino 101 and Grove sensor kit are used, along with the Photon Red board, appropriate sensors, and actuators. Wiring and installation are simple. The sensors were strategically placed within the lizard tank and wired to the boards contained on the outside of the tank. We created a box to hold the electronic elements to help with installation and to protect the electronics from harm.
There are 3 major components of the programming: sensor and actuator control, communication architecture, and UI development. The light sensor and stepper motor from the Grove kit are used, along with the humidity and temperature sensor, a moisture sensor, and a peristaltic pump to regulate soil moisture. We also used a mister for humidity regulation and UV and fluorescent lights for night and daytime lighting. The 101 receives data from the sensors and reports the data to an analog.io stream. This is then presented to the user through our web page, where the user can either manually control the various actuators for the system or allow the tank to control the actuators with minimal user input.
This is the main module for the whole system. It's the Advanced Computer Containment Unit, and we have our 101 with our shields here and our SparkFun Photon Red board, and you can see them hooked up here, SDA and SCL for I2C, and the 101 constantly pulls the photon for the state, and the state is gotten from our web page. And so here's the web page. You can see here the current data values, and there's supposed to be a data stream here. These right here are manual controls here, and these are ranges that are set to control like the environment. So you can have a maximum humidity of, say, 89 or whatever. The manual functions here. So right now we're in day mode, as you can see. So that's day mode, and what I'll do is I'll set it to night mode. And using particle functions, it sends to the photon that we are now in state, I believe it's 3, and it switches it to day mode, or to night mode. And then we had day mode, and it's now in day mode again. So yeah, and that's one of the modules that we have affixed to this system. Modules are anything modifying the environment, and fixtures are anything that sense it. Speaking of modules, we also have back here our soil moisture pump, which adds to the soil moisture for living plants, for actual plants, in the event that our soil moisture is too low. But there's a soil moisture sensor far in the back there, and the pump, whenever it detects that the soil moisture is too low, it turns on, and it pumps through this tube into the lower layers of the soil. And that just helps keep everything nice and humid and keeps plants watered. Along with humidity, we also have a little donut humidifier floating in that pool there. And that little atomizer is triggered, of course, whenever the humidity sensor is sensing that the humidity is a little too low. That's also a temperature sensor, by the way. And so whenever the humidity is too low, the atomizer turns on, and you start seeing all this mist come out. Very handy little device. It was only a few bucks, and it's a 5-volt operating voltage, so it was like perfect for Arduino hacking. Using the Grove stepper motor, the seed stepper motor, we also created a feeding mechanism. This houses crickets with this little like sort of water wheel type design. And every time that the crickets are fed, every time that the feed function is called, then that stepper motor turns and just dispenses more crickets.